Hello everyone. In this second video of today's lesson, I'm going to be diving a little bit deeper into recursive structures. So in the first video, we talked a little bit about what a recursive structure is. So a recursive structure is just an object that is defined in terms of itself. So in the previous unit, we've been talking about how to define classes. So a class definition defines our own custom data types with attributes and methods. So on the right-hand side, we have this node class that has two attributes, this data integer and then this next node. And so this is a recursive definition because the attribute next is referring to another object of the exact same type. So within our node class definition, we're referring to another object of this same node type that we're in the middle of trying to define. So an analogy here is if you were looking up the definition of a word in the Webster English Dictionary, and you get to the entry for that word on the page, and you're reading the definition, and it uses that word within the definition, right? You'd be a little confused. That's not very helpful. That would be an example of a recursive definition if the word you're looking up appears in the text of the definition. And so reading and parsing these recursive definitions can be a bit challenging, but we're going to work through it together. And so this class node is an example of a recursive definition. And so I'm just going to jump over into this next tab to draw this out for a second so we can visualize this together. All right. So let's see. So each individual node object on the heap is going to look something like this. So each node object is going to have a data attribute and a next attribute, right? Because the class definition, you can think of that as just the recipe for constructing each object in the heap. And so the data is going to be some integer, so we can say this is 1, right? But then the next attribute is going to be some other node. And so if we're constructing a node that requires another node as its next attribute, okay, so we can do that, right? That just means we have to make another one. So we'll go ahead and make another one. And so that next node also requires a data and a next, and so we'll give this data attribute 2. It also has a next. Okay, so this next is also a node. This node is going to be of the same structure. It also will have a data and a next attribute. Okay, but do you see this pattern? Every single node we construct is going to require this next attribute. And so what we're seeing here is a sort of infinite recursion. Okay, and so we're going to discuss in a few minutes how to initialize a recursive property to avoid this infinite recursion. Because when we construct a single node, we don't want to have to construct an infinite chain of nodes just to make one, right? So we'll discuss a solution to this problem in a few minutes. Before we go any further, I just want to highlight that this basic node class that I showed on the previous slide is actually used as a building block for many recursive data structures that you'll see in Comp 210 if you choose to go on, and can be used to build many more complex things that are beyond the scope of this class, but I just want to take a moment to draw some of the things out here. So, all right, so today we're going to be using this node class to just construct a singly linked list. Okay, and so I kind of already showed this on the previous slide when I was trying to construct that single object where all of the nodes have data and then this next attribute that's connecting the nodes together into this singly linked list. Okay, so for example, right here we have, this is an example of a singly linked list of length 3, right? Okay. And so the reason it's singly linked is because the arrows only point one way. We could change this into a doubly linked list, and you'll see this in 210 if you go on. We would need to add backwards pointers or backwards references where you would have like some previous attribute, right? And so the previous would, oops, I don't know why that arrow got all funky. The previous arrow would take us backwards. Okay. So that's one example of things we can do with our, with our nodes. So like I said, today we're just going to be focused for our purposes in 110 on talking about the singly linked list. So the singly linked list is formed by chaining together sequences of objects, and so these objects are just instances of this node class that we've defined that just has two attributes, some data and some next reference. All right, and so the first node is conventionally called head, and so we'll see this in a moment. But typically, when you're instantiating a new linked list object, you're going to call the variable head. And so when we're diagramming this together, the variable name that we'll be writing on the stack will be head, and that will be an arrow to the start of the linked list node that begins the chain of objects. Right. Our focus, again, is on singly linked lists, meaning a node only references the node immediately after it. All right, and just a note that these linked lists are more cumbersome to work with than Python's built-in lists that you all did a nice exercise with earlier in the semester, but they're great for understanding these fundamental concepts of recursion and references. So at this point, I am going to jump right into code so we can start building this together. Alright, so here in my workspace I've created a new lesson, so let's go ahead and get started. So I'm just going to call this a simple linked list example. Alright, and so we're going to need this import statement to allow us to define a recursive data structure. And so I'm just going to start off and just start off with this simple node example that we saw on the slide, where we had two attributes, this data and this next node reference, okay? And this is just a single linked list node. That's all we're working with right now. Okay, and so why am I getting this error? Here we go. All right. Oops, sorry. My bad. From future import annotations, not from future from annotations. Okay, so now that we've got this basic class set up how we had on the slides, let's go ahead and define a constructor for it so we can construct node objects, and from that construct some linked lists. So remember, in Python the constructor is _init, and in Python, again, every single method starts with this self special magic keyword. And so we're going to have two parameters for this constructor. Oops, sorry. And give it a docstring. And so all we're going to do is we're just going to take these attributes and assign them to be whatever was given to us as arguments in the constructor. Okay, so pretty standard constructor here. But what happens if we now try to instantiate a new node object, okay? So if we say a node is a new node object, right, we would now be able to call the constructor with some set of arguments. So we'd say 1, and now as the second argument, we'd have to provide some next node. And so here we start running into a problem. And so at this point, we would have to provide a second node as our argument. Oh, but we don't have one, so what would we need to do? We'd need to go and declare one, go construct one. So we can do that. All right, cool. Second node, the data can be 2. Oh, but now our second argument is some next, right? That's a problem. Okay, but we fixed the problem for a node, so we can go fill that second argument in. Line 18, a node is constructed. We successfully constructed a single node. Cool. But second node isn't done, right? Okay, so we need to go fix that. So we have to construct a third node to fill in for second node. Next reference. Okay, so as you can see, this just becomes an infinite chain of unfinished objects, right? Because we have no way of terminating this list. So we started our list with a node, okay, and its data had 1 in it, and then we constructed a second node to be its next, okay. Second node, we constructed, right? It had 2 in its data. We constructed a third node, but now we're having this problem, right, where we just have to construct infinite nodes to be supplied as the next attribute, and we have no way of terminating this list. Okay, and so on the next slide that I'm going to jump back into, we can talk through how to solve this problem. All right, so the idea of terminating recursion is called a base case. And so, like I mentioned in the previous video, whenever you're working with recursion, whether it's a recursive structure or a recursive process, you always want to be thinking about in the back of your mind, how am I going to make sure that this stops, right? Just like when you were working with loops earlier in the semester with your while loops, for loops, you wanted to make sure you didn't have an infinite loop, right? Because that would crash your program, crash the grader. Same thing here. You do not want to have infinite recursion either, okay? And so the way that you terminate recursion, whether with a structure or with a process, is through a base case. So what does it mean for a recursive structure to have a base case? For us, like in this case with this node class, like if a node is referring to a next node and the next node refers to another next node, like when can this possibly end? And so the way we're going to terminate this is with a none value, okay? And so in many other programming languages, this is called null. And so if you took AP Computer Science or some other language, or a class with some other language that uses null, like with Java, you may have seen that. And so this is just like a way of saying a reference to nowhere. You can read this as like the attribute refers to nothing. And so the way we're going to do this is with optional types. And so for the last few weeks, you all were working with the SIMPy exercise. And so with that, you saw the idea of union typing. And so optional typing is just some nice syntax wrapping around union types with none. And so the union of some non-none type and none can just be replaced by the optional type of X. So let me just do a quick example of that in case, or quick concrete example of that in case that's like confusing. So like if you had some union type of int and none, this is the same thing as optional int. So this is saying, like, if you give the variable the type union int, none, you're saying the variable can either be an integer or it can be nothing. So that's, if you're thinking of it in English terms, it semantically sounds the same as saying like this variable is optionally an integer. It can either be an integer or it can be nothing. And so this is how we're going to fix the issue of our infinite recursion in our linked list. Alright, so in order to use this optional typing, we have to import it, just like we had to import the union typing. Okay, and so everywhere that we have this node with our next attribute, we're just going to wrap it in this optional type. So next is now not just declared as a node, it's an optional node. So the next attribute can either be a node or it can be nothing. Same thing here. Okay, and so now we can finally terminate our list by giving this third node a none next attribute. So we finally have a complete linked list with just 3 elements. Okay, and so if we go back to the slides for a moment, I just want to go ahead and diagram what this would look like. So in globals, we have a class node. Oops, sorry, that is bad handwriting. All right, I just want to diagram together what this would look like. So we have our stack, and we have the heap. And so we have, in globals, we have the class node, which is a class defined on lines 8 through 16. Okay, and so the first thing that we have is on line 19 is this third node is a name that is given some space on our stack frame. Sorry, I forgot to write the name of our frame here. We're in the globals frame. All right, and so we call the we call the node constructor. And so the first frame that we add to our stack after the globals frame is a node constructor frame. So we're going to add a node init frame, and so we were called from line 19. All right, and so since this is a constructor frame, we know that the whole point of a constructor, right, is to set up a brand new node object. And so this self parameter is going to be referring to a brand new node. And so every node has these 2 attributes, data and next. And so the two parameters that we were given, so we have data and next. So the parameter for data that we were given on line 19 was 3, and the next we were given was none. Okay, and so on line 15 of this constructor call, we follow the arrow to self, and it says self's data attribute is assigned whatever our data parameter is, which is 3. And our next attribute is assigned whatever the next parameter is, which is also none. Great. All right. And then once this constructor frame terminates, we return this node, and that is what populates the third node variable. All right, so that is line 19. Continuing on line 20, we have this variable second node. Okay, and so second node is another variable declaration and initialization statement where we're calling the node constructor frame. And so the RA is now line 20. Okay. The self is going to be some brand new node whose data, and next we're going to fill in a moment. The data parameter we were given was 2, and the next parameter we were given was third node. Okay, so that means this next arrow is pointing here. All right, so on line 15 it says, follow the arrow to self within this second constructor frame and update data to be whatever was passed in as our data parameter, which was 2. Then on line 16, follow the arrow to self, update self's next attribute to be whatever was passed in as the next parameter, which was this node object referring to the third node. Okay? So here, right here, we're creating a reference from this node on our heap with the data 2. Its next attribute is now pointing up to the node that has the data 3. Okay, and that is getting returned from this constructor frame. Okay. This had a return address of 20 and gets returned back into the second node variable. Okay, and I'm going to use some other colors maybe to help highlight what's happening. Okay, so second node, so this one. Okay. All right. Great. Then on line 21, we have one more variable declaration statement where we declare a node. And this is another variable declaration statement that makes a call to the node constructor on the right-hand side. Okay. So the data we were given as a parameter is 1, and the next we were given was the node held in the second node variable, which is up here. Okay, and so within the constructor frame, on line 15, we follow the arrow to self and update the data attribute to be whatever is held in the data parameter, which is 1. Then on line 16, we follow the self arrow, update that next attribute to be whatever is held in the next parameter, which links up the final link in our linked list to like so. Okay, so this is the head of our list. A node is the head of our list, and so I probably should have named this head. So you can imagine that a node is head. This is the beginning of our linked list. Okay, and so this final constructor frame returns this linked list. Okay, and so a node is referring to this list beginning with this node with the data with 1 in it. Okay, so let's take a look what just happened. So a node refers to a single node that has 1 in the data attribute, but its next refers to another node, which refers to another node. So in total, we have a linked list with 3 nodes in it. Okay, so a node is the beginning or head of a linked list of length 3. Okay, and that makes sense because we see 3 calls to the node constructor. All right, so this diagram here is the result of these 3 lines of code. And diagramming these types of recursive structures is definitely takes some getting used to, and keeping the arrows straight is a challenge, so I encourage you all to definitely practice on your own. All right. The last thing I want to talk through, and I'll go over it in the code, is the fundamental operators of our linked list. And so you can construct a new node at the front of another linked list via the node constructor. And so we just saw an example of this. So we just saw how to construct a linked list of length 3 via the node constructor. You can also access a linked list first value via the data attribute, and you can access the rest of the linked list excluding the first node via the next attribute. So let's go ahead and check this out. So here I could print a node.data, and so then down in my terminal I could do python-m lessons.ls28 linked list, and I see I get 1. I could do a node.next, which should give us that second node, and if I do .data, that should give us the data attribute of the second node, which would be 2, all as well. If I rerun that, that looks great. And then if we do .next, right, that should be 3. If we do the data there, and great, that's what we get. All right. However, what happens if we do this? We get none, right? Because the next attribute of our last node is none. However, if we go 1 too far, we get an error, right? Because there's no next attribute of something that, or the none object has no next attribute. All right. Great. So this wraps up all that I wanted to say for right now about recursive structures. I'm going to jump next into a video about recursive processes and then see how we can bring both ideas together.